Welcome to the 123 Lab 1. This is pressure in a fluid, and we're going to be conducting the experiment for you. This is how we're going to have to do things with the coronavirus epidemic. And so we'll just produce these videos, and you just fill out the lab sheet as normal and submit it electronically, and we'll give you all the data that you need and explain the equipment as well. Okay, so this equipment here is pretty simple actually. All we have is a jar down here, a glass jar. It has a red colored liquid of unknown density that you're going to be trying to measure. The top of the jar has two tubes. One of them runs up here where the water will go, or it's not water, but where the liquid will go up as we pump. And this is open to the atmosphere. This is here to try to prevent spills, but it is open to the atmosphere, so you could treat it as if it's just cut off. And then the other tube here is where we're going to put air into the jar. And so this tube, we have a pump, just a squeeze bulb, and there's two one-way valves here. And so if we squeeze it, the air can't go out this way, but it'll go through here and into this tubing and down into the jar. When we release it, no air can go this way, and so all the air comes in from here, from the atmosphere. So when this is open like this is just atmospheric pressure in here. We squeeze it, puts the extra air molecules into the jar, and we can read this on the gauge here. This is in ounces per square inch, and this measures how far above atmospheric pressure here in the tube as well as in the jar we are. And there's just a simple release valve here where we can open it and it'll let the air out, and we can see that it goes back to zero, meaning that at zero it's just atmospheric pressure inside the jar. Okay, so let's go ahead and do the experiment. We're going to pump up some pressure in here and measure the pressure. Again, this is the pressure inside the jar where the air is. And then that's going to cause the added pressure inside the jar is going to cause the liquid to come up in this tube here to some height. Doesn't really matter which height, we're just going to arbitrarily pick one in this range. And then we're going to measure the liquid at that height, and then as well as the height of the surface of the liquid down in the jar. And then from those two heights, as well as the pressure on the gauge here, that's all the information you're going to need to find the density of the liquid. So let's go ahead and get started here. I'm just going to squeeze the bulb repeatedly. We can see the liquid rising as we're adding pressure, and that looks about good. So let's look at the reading here. Again, this is in ounces per square inch, so you'll probably have to convert that to SI units. You can just look on Google, or I think it has the conversion on your sheet as well. This is the height here. That this is 1 meter plus 60, 3.5 ish, because we're already at the meter mark. And then we come down here, and we want to measure the jar. And so the ruler's kind of beat up here, but this is at 7 point maybe 4 or 3. I'd go with 3. 7.3 centimeters above where the ruler starts. So 7.3 all the way up to 160 whatever you measured. And so that's all the data that you need. In case you get stuck, here at the end, I'm gonna go through a couple hints that may help you on going through the lab sheet. Okay, so the key to this lab is to understand what is happening inside the tube at the surface of the liquid here. And so if we think about it, the pressure inside the air, right, is what we're measuring on the gauge. The absolute pressure inside this jar where the air is the gauge pressure plus the atmospheric pressure. And that pressure, we can relate it to the pressure at the surface level inside the tube. And so maybe think about what would happen if the pressure inside the tube at the surface was maybe greater or less than the pressure in the air cavity, and how the fluids would adjust. And there's an equilibrium position, okay, where you can find the pressure inside that tube in terms of the pressure inside the air. If it's really simple, you got it right. Once you know that, it's really easy to just apply the equations, give it on your sheet, and find the density.